Welcome back. Today we're going to be on lesson 8.3.4. And in this lesson we're going to be learning about special cases of factoring, sums and differences. So, what does that mean? It means you guys are going to learn shortcuts, and you guys are going to love this lesson. Because if you can recognize these patterns, then you can immediately put it into that form that you remember, that form given to you. So, let's do the first one. You may remember what a difference of squares can be factored using the following pattern. A squared minus b squared equals a minus b times a plus b. Which of these are differences of squares? Factor the ones that are. So, you guys are thinking, wait, but this is not for polynomial functions because we've already seen these. You are correct, but we're going to expand upon that and put them to polynomial functions. And we're going to make it easier for you guys, if you guys recognize the pattern, to factor polynomial functions. It's going to be great. You're going to love it. So, a squared minus 4b squared. Does that follow a difference of squares? Yes. Yes, it does. Because the 4 is a difference of squares. B squared and a squared are obviously a difference of squares. So we're going to do a minus 2b times a plus 2b. There we go. So 2x squared minus 16. Is that a difference of squares? No, because 2 is not a difference of squares, even though the 16 is. And if we factor out 2, well, yeah, it becomes a difference of squares for the this side, but then it's minus 8. And 8 isn't a difference of squares. So, not a difference of squares. There we go. All right, let's do this one. Wait, but the negative is in the wrong spot. Easily fixed. We're going to factor out a negative 1. X squared minus 4y to the 4. So let's look at the inside. Is that a difference of squares? Yes, you guys are absolutely correct. It is a difference of squares. So negative 1 times x minus 2y squared times x plus 2y squared. There we go. And I didn't give myself enough room for the other part. Well, which is fine. So, if there's a positive, can we ever make one a positive and one a negative to use difference of squares if they're both positive? No, but we can make both negative. Will that help us? No. So, not a difference of squares. There we go. So only 2 of them were difference of squares. So, now that we kind of remember what difference of squares are, let's do the next set of problems. So, it says the following are sums and differences of cubes. Use the given factor to divide the polynomial and write the results in factored form. All right, so you guys are like, well, okay, now we're getting to polynomials. Are we going to learn new patterns? Well, I'm not going to say anything, but hopefully you guys recognize a pattern. I'll show you the pattern afterwards, but let's just do them. So, x minus 1, we get 1. We put 1 here, right? Because 1 is a factor. 1 is a root of x minus 1. And now we're going to have to put in 1 for x cubed. Oh, we don't have a squared. X squared, so 0. And we don't have an x, so another 0. And then we put negative 1 at the end. So we bring down the 1. 1 times 1. 1. Add 1 plus 0. We get 1. 1 times 1. 1. 1 plus 0. We get 1. 1 times 1. Oh, that gives us another 1. Negative 1 plus 1 gives us a 0. So yeah, it was a real root. And our factored form is x squared plus x plus 1. That is its factored form. Right there, we're good. And if you want, you can multiply by x minus 1 to get the answer. All right, let's do b. So negative 2 is our root for x plus 2. So we're going to get a 1, a 0 because we have no x squared, and another 0 because we have no x, and an 8 because that's our constant. So we're going to bring down the 1. 1 times negative 2. Negative 2 plus 0 equals negative 2. Negative 2 times negative 2, 4. 4 plus 0, 4. 4 times negative 2 equals negative 8. Well, would you look at that? You get a 0. All right, let's put it in factored form. X squared minus 2x plus 4. There we go. Are you guys slowly seeing a pattern? Slowly, kinda, not really. Maybe the next two will will solidify your initial thought process. If you don't see it, don't worry about it. Once I tell you, you guys can be like, oh, I get it. And that's the important thing, you guys understanding these problems. So I already wrote in 3 because 3 is a factor of x minus 3. 3 is a root of x minus 3. X minus 3 is a factor. So 1, no x squared, 0, no x, 0. And we put negative 27 at the end because that's our constant. So we're going to bring down the 1. 1 times 3, 3. 3 plus 0, 3. 3 times 3, 9. 9 plus 0, 9. 9 times 3, 27. 27 plus negative 27, 0. So what's our factor? X squared plus 3x plus 9. All right. We have enough for our first pattern, right? It happened twice. So let's look at A and C. In A, you divide an x minus 1, and you get x squared plus x plus 1. Here, we took out an x minus 3, so we get x squared plus 3x plus 9. So the first thing I see is that the middle variable is always going to be positive if we factor out x minus 1. If the original polynomial is in this form, right? The other factor that I notice is that all these are going to be the next two variables are going to have either a leading coefficient of a factor of whatever's the constant of the original polynomial, and the constant is also going to be a factor of that original polynomial. So if we look here, it's 3 and 9. So 9 is sort of like the last factor. So you're going to get 3 times 3 gives you 9, and then 9 times 3 gives you 27. So it's going to be the first, because it's a cubic function, right? And we know that it's 3 times 3, which gives you 9, times 3 gives you 27. So the first one is 3. And then when we square 3, we get 9. And when we cube 3, we get 27. And that also works out here, because if we cube 8, cube root 8, we get 2, which we put here. And if we square it, that's what we put there for the constant. We'll see it when you see it more when I show you the next page. So let's do D. And you can already guess from this that the middle variable is gonna be a negative. So we're gonna do a negative 5, 1, 0, 0, and 125. So we bring down the 1. 1 times negative 5, negative 5. Negative 5 plus 0 is negative 5. Negative 5 times negative 5 is 25. Plus 0, 25. 25 times negative 5 equals negative 125. And we add those together and we get a 0. So now we're going to put it in factored form. X squared plus, minus 5x plus 25. Jumping the gun, it's just going to add 25 and leave out the negative 5x. So let's do the next page and we'll go over those patterns even further. So remember how, in this problem, we're going to identify the factoring pattern for sums of cubes and difference of cubes. So hopefully from the previous problems that you have figured out some sort of pattern in those. And I did go and share those patterns. So let's do x cubed plus a cubed. So we're going to do x plus a. X plus a times, because all of them have to be positive, except that because it's all positive, we're going to need to get rid of what's in the middle, doing x minus x squared minus xa plus a squared. I didn't want to do ax and confuse you guys, so that's the way I wrote it. Because a is at the end, x is in the beginning. If a was at the beginning, it would have made more sense. But here you go. That's the sum of cubes. That's the identifying factor. So, and what do you think the difference of cubes is going to look like? It's going to look like x minus b, because you're going to take that, the original, without the cube. And then what's left? X squared plus, because we already have a negative, plus xb plus b squared. Because negative b will give you a negative, like positive a, and positive a will give you positive x. X give you a negative. And we're hoping that all of the middle, well, we're not hoping, we know that all of the middle parts are going to equal 0. And all we're going to be left with is x cubed plus a cubed. And if we look here in the math notes, it shows you all of the formulas for differences of squares, sum of cubes, difference of cubes. So if you remember these formulas, you could just go ahead and do them, put them right in. You don't need to do what we've been doing, synthetic division and all of that. We can start using these if we notice the pattern. And we will notice the pattern. So let's do the first one, ax cubed plus 27. What is that? Sum of cubes, difference of cubes, or difference of squares? Sum of cubes, because two cubic functions are added together. But let's put it, here I'm gonna write sum of cubes, but let's put the latter half, let's put them all in the a cubed plus b cubed format, right? So what's the cube root of 8? It's 2x. And if we cube that whole thing, we get 8x cubed. So how do we, what's the cube root of 27? 3. 3 cubed. Can we now use one of the sum of cubes formula to solve for the factor? Not solve, evaluate the factor, get the factor? Yes. So we're going to get 2x plus 3 times 2x squared, which is 4x squared. I'll put it in 2 steps. 2x squared minus 6x plus 3 squared. So if we solve that whole thing out, we get 2x plus 3. We get 4x squared minus 6x plus 9. And there we go. That is our factor. All right, let's do the next one. 125x cubed minus 64. Right, difference of cubes. And you can usually tell if it's cube or square by the x. What, x to the power of 3, cube, x to the power of 2, square. Right? All right, so what's the cubic root of 125? 5. So 5x minus 64. What is the cubic root of 64? Right, 4. So now, can I use the difference of cubes? Yes, I can. So I'm going to do 5x minus 4 times 5x squared plus 5x times 4, which would give me 20x plus 4 squared, which would give me 5x minus 4 times 25x squared plus 20x plus 16. All right, next two. 81x squared minus 25. It's already given the degree, and it's being subtracted. So it's the difference of squares. All right, so we're gonna need a square root 81 and square root 25. So I got 9x squared minus 5 squared. All right, let's do this. So if we're using the difference of squares, 9x minus 5 times 9x plus 5. And that is it. Oh my god, I forgot to use the highlighter. I like to use them on the free response looking questions so you guys know what my final answer are. There we go. My bad. My bad. All right, let's do this one. So is this a difference of cubes, difference of squares, or sum of cubes? Right. Sum of cubes. You guys are looking at me like, but what's the cubic root of 1? We'll get there. Let's do the cubic root of 16, which is 6x cubed plus 1 cubed. anything to the power of 1, anything to 1 to the power of anything still gives you 1. You know, we're good to go. So for the first one, I got 6x plus 1. Then when we put them in the formula for sum of cubes, I got 6x squared minus 6x plus 1 squared. All right, so then my final answer is going to be 36x squared minus 6x plus 1. Now, time to highlight my answer. And there we go. This is lesson 4.3.4, hopefully 8.3.4. When you guys see me, if you have any questions, please feel free to ask me. Maybe about the pattern, how the pattern was found and all that. Just look through the problems that we did. Problems right here. And try to find the pattern yourselves before asking me any questions about it. Thank you, and that's it for me for this section.